Hello, Mr. Kobalek again. Welcome back, Fruitport High School students. Let's take a look at number 2 from the BCA tables. We won't do all of them, but I want to do another one because this one's a little bit different here. So number 2 in your packet of notes here asks this question. Propane burns in air to form carbon dioxide and water. If 12 moles of carbon dioxide are formed, how many of moles of propane were burned? All right, so this is a unique one that we're not even given the equation, so we get to practice all of our skills from chemistry A and chemistry B to make this here. So it says propane is burned, which is C3H8. And for anything to burn, it has to burn with oxygen. Don't forget that oxygen is O2, not just O, and it makes carbon dioxide and it makes water. So this is a classic combustion reaction. All right, to balance this one, I'm going to go ahead and use maybe a orange number to give the balanced equation here. And so I see 3 carbons here and not 3 carbons here, so I'm going to need a 3. I see 8 hydrogens here. I don't see 8 hydrogens. But if I had made 4 waters instead of 1 water, I would have 4 hydrogens. And the oxygens, all right, it's got 5. No, I almost added, but we multiply 3 times 2 to get 6 oxygens. Plus there's 4 more, so there's 10. So if I put a 5 here, this will give me 10 oxygens on this side. Okay, so our balanced equation is 1 of these plus 5 of these makes 3 of these and 4 of these. Remember, this 1, 5, 3, 4 ratio is really important for the change column of the BCA table. Okay. All right, what colors did I use on the last time? Let's read again here. I used the pink to tell us what we know and yellow to ask what we're asking for. So here, if it says 12 moles of carbon dioxide are formed, this means that we're going to have 12 moles of carbon dioxide at the end, in the after phase of this reaction, 12 moles. We're actually starting with the number way on this side, and they're asking us how many moles of propane were burned. So this is the key box that we need to fill in. I'm going to do the whole box to help us out for this, but you guys will only need some of the columns. A couple other things that are worth pointing out is we can, for this beginning part of the class, always put zeros here for any products after the arrow. We're going to assume we have 0 starting materials. All right, I'm going to switch to the green marker again to fill in the rest of the box. Remember, the before plus the change is always the after. And so in this case here, I must have a change of positive 12 because 0 plus 12 equals 12. Okay, now if I want to fill in the rest of the changes, I have to pick numbers that have a 1, 5, 3, and 4 ratio. I know that this number is going to be a 4 because 1 to 3 is equal to 4 to 12. Again, I'm only looking at the balanced equation to do the change column here. But this is going to be a negative 4. You're probably thinking, well, where did that negative 4 came from? Well, any changes on this side of the equal sign, yields arrow are negative, and these are 12. Now, if I wanted to practice filling in the rest of the table, which I think is worth it, this number here is going to be negative 20. And why? Because, well, 5 is 5 times bigger than 1, and 20 is 5 times bigger than 4. Negative, again, we're on the reactant side. And this number here would be positive 16. Because 16 is 4 times bigger than 4, just like 4 is 4 times bigger than 1. But positive because we're making this. Now, if I wanted to fill out the rest of the table, I always add up. 0 plus 16 is 16. Let's say we used all of these materials. Then we're going to have to start with 20 moles of oxygen, and we're going to have to start with full moles of propane. We've actually finished answering the question. The question was how many moles of propane were burned? The answer is right there. 4 moles of propane were burned. Now, I will again grab the blue highlighter just to point out that I don't think we actually had to fill out this column or this column to solve the question, but in the advanced ones coming, we will need the whole table. So I'm just giving you some practice here. Again, I figured out, how did I figure out this yellow box? Well, I figured out this change was 12, so this change must be 4 because of the 3-to-1 ratio. And I had to figure out that 4 plus -4 equals 0. So I kind of worked backwards with some algebra that the B plus the C always has to add up to A. And like maybe it wasn't so obvious, but we're asking like if we burned all the propane and we had no propane left over after, how much we'd have. All right, I hope this works and you're learning.